This question is from Physics chapter Capacitance. Here it is given that a parallel plate capacitor having area is 25 centimeters square and the separation is 1 millimeter. It's connected to a battery of volt 6 volt. Calculate the charge flown through the battery. This is the first part of the question. In the second part, how much work has been done by the battery during the process. So let's understand this question with a figure. As you see in the figure, we have a parallel plate capacitor. These are the two conductors and the separation between them is 1 millimeter. Area of the plate is 25 centimeters square and it's connected with a battery of 6 volt. So this area is given in the centimeters square. So we can write area is equal to 25 into 10 to the power minus 4 meter square. Similarly, the distance is 1 mm. It can be also written as 1 into 10 to the power 3 meter. Now in the first part of the question, we have to find how much charge is flown through the battery. This Q we have to find. So we know that Q is equal to C into V. C is the capacitance, V is the voltage. So V is already known. This part we know its value is 6 volt. But capacitance we don't know. So first work is to find the capacitance of a parallel plate capacitor. So capacitance formula is equal to C is equal to E naught A by D. So based on this formula, we first find the capacitance. E naught value we can substitute 8.85 into 10 to the power minus 12 farad per meter. This is the epsilon naught value. Area is already given here and the distance is also known. So let's substitute the value. C is equal to 8.85 into 10 to the power minus 12. Area is 25 into 10 to the power minus 4 and the distance is 1 into 10 to the power minus 3 farad. C is equal to 8.85 into 25 into 10 to the power minus 13 farad. So C is equal to 22.125 picofarad. We got the capacitance value. Now we can substitute this capacitance value in the charge formula and we can find the charge. Q is equal to C into V. So from here Q is equal to 22.125 into 10 to the power minus 12 and the voltage is 6 volt. So the total charge is 1.33 into 10 to the power minus 10 coulomb. So this is the answer for the first part of the question. In the second part of the question, we need to find how much work is done by the battery during the process. So for this we can use the work formula. W is equal to V into Q. Because they are asking with respect to the battery. So based on that work we can find and its formula is V into Q. So W is equal to V is given as 6 volt. Charge we got 1.33 into 10 to the power minus 10. So W is equal to 7.98 into 10 to the power minus 10 joule. So this is the answer of this question.